Cosmology. The science of the origin and development of the universe. Modern cosmology is dominated by the Big Bang theory, which brings together observational astronomy and particle physics. Cosmology is the study of the cosmos, which is the entire universe. Someone who studies cosmology is interested in the structure, origins, and development of the universe. In cosmology, the major theory of the origin of the universe is the Big Bang theory, the idea that 12 to 14 billion years ago, a small amount of hot, dense matter began expanding, eventually cooling and forming the stars and galaxies we know today. Cosmos comes from the Greek word kosmos, which means world or universe, and cosmology comes from the cosmos. Don't confuse cosmology with cosmetology, which is the study of beauty treatments. The Doppler effect, or the Doppler shift, is the change in frequency or wavelength of a wave in relation to an observer who is moving relative to the wave source. If we look at the stars and galaxies in our universe using a simple optical telescope, it is impossible to tell if they are moving, and if they are moving, then how fast or in which direction. If, however, we look at the spectrum of light emitted by a star of a galaxy, we can discover all of the above. We can do this by using an effect called the Doppler effect, first described by an Austrian scientist named Christian Doppler in 1842. Before we look at the Doppler effect in space, let us look at some more familiar situations where we can observe it. If we close our eyes and listen to the engine of a fast-moving car, it is usually very simple to decide if it is approaching us or moving away. The loudness of the motor will of course change, but so too will the frequency of the sound we hear. As the car approaches, the frequency of the sound produced by its motor appears to be high, but when it moves away it appears to have a lower frequency. This apparent change in frequency is called the Doppler effect. The faster the car is moving, the greater this change in frequency. The Doppler effect is a property of all waves. It happens not only with sound waves but also with light waves. When astronomers look at light spectra from distant stars and galaxies, they can see the Doppler effect. Figure 28.3 shows the spectra from 4 different objects. The first is the spectrum from our Sun. The dark lines we can see are called absorption lines. They are the frequencies of light that have been absorbed by hydrogen. The second spectrum is from a nearby galaxy. Here we can clearly see that the positions of the dark lines have moved towards the red part of the spectrum. The third is the spectrum from a very distant galaxy. The lines have moved even further galaxy. We call this displacement redshift. Like the changes in the frequency of the car engine, it indicates a relative motion between the galaxies and the observer. Redshift indicates that the source of the light waves is moving away from the observer. Blue shift would indicate that the source of light is moving towards the observer. Figure 28.4 demonstrations of light from a star moving away from Earth and moving towards it. When we compare the light emitted from all the different galaxies, a clear pattern emerges. Almost all the galaxies emit light with red shift. The further away a galaxy is, the greater the red shift, and therefore the faster it is moving away from us. We see exactly this pattern in situations that involve explosions. Figure 28.5. As the bun expands, the currents get further apart. Similarly, as the universe expands, the galaxies get further apart.
The Doppler effect. Specification point 3.8. Explain why there is a change in the observed frequency and wavelength of a wave when its source is moving relative to an observer, and that this is known as the Doppler effect. Usually, when an object emits waves, the wavefronts spread out symmetrically. If the wave source moves, though, the waves can get squashed together or stretched out. When a wave source moves, the waves in front of it get squashed together. The waves behind get stretched out. This causes the wavelength, and frequency, of the waves to change. The wavelength of the waves in front of the source decreases and the frequency increases. The wavelength behind the source increases and the frequency decreases. Think about the sound made by a racing car as it first moves towards you and then moves away from you. This effect is known as the Doppler effect. The Doppler effect also affects light, changing the frequency and wavelength of light being received from moving objects. If an object moves towards an observer, the wavelength of light decreases. This is known as blue shift, as the light moves towards the blue end of the spectrum. If an object moves away from an observer, the wavelength increases. This is known as redshift, as the light moves towards the red end of the spectrum. When a star moves towards an observer, the light is blue shifted. When it moves away, the light is redshifted. The speed of galaxies may be determined by measuring the change in the wavelength of light coming from that galaxy. The equation below shows us how to calculate the speed at which a star or galaxy is moving relative to us. Change in wavelength. DL reference wavelength lambda 0 equals velocity of a galaxy v speed of light c. In the above equation, O lambda 0 is the wavelength of light for a stationary observer, the reference wavelength, as measured in a laboratory, and lambda is the measured wavelength. ODL refers to the change in wavelength.